Welcome, everyone. Thank you for attending today's presentation, Phoenix WinNonlin, a state-of-the-art tool for preclinical PK/TK analysis. My name is Suzanne Minton, and I'm a marketing specialist at Certara. If you experience technical difficulties joining this WebEx, please dial 1-866-229-3239 if you're located in the United States or Canada. For all other countries, please dial 1-408-435-7088. To eliminate background noise, all phone lines will be muted for the duration of the event. Next slide, please. Please feel free to ask questions at any time during the event by clicking on the question mark icon on the floating toolbar located at the top of your screen. Please be sure to address your question to the default selection in the Q&A so that it goes to all panelists. We will address as many questions as possible during the Q&A session following today's presentation. This event will be recorded, and a link to a replay of today's webinar will be emailed within the next few days. Before we begin today's presentation, I would like to introduce the speaker, Chris Mell. Chris is currently a customer support manager and software trainer at Certara. I'll now turn it over to Chris to begin today's presentation.
Thanks, Suzanne, and thank you everyone for attending today. Good morning or good afternoon, depending where you're calling from. This presentation will be of the Phoenix software developed by Certara Corporation, and the core component I will be presenting is WinNonlin. WinNonlin is an industry standard preclinical PK software, and this is going to be presented in the Phoenix platform, which is designed for ease of use and some powerful new plotting data tool capabilities and ease of use and sharing work with colleagues. So on my screen is the Phoenix application. The latest version is version Phoenix WinNonlin 6.3. And when using Phoenix, the first step is always to use a project. So I can either open a new project or load an existing project. In this case, we'll start with a new project. And the project has a structure to it. So in the object browser on the left, at the top, you will find the project name. There is a data storage container for input data. Custom code such as scripts or custom models can be stored here. The tables folder is for outputs, and BQL rules is a place where one may do BQL replacements below limit of quantification rules. Companion documents such as Word documents or PowerPoint slides can be stored here. And then the main workflow is where all of the analysis steps are performed. So in this first example, this will be a two-period crossover study with two different formulations. And to get data into the Phoenix application, use the File Import menu. And locate your input data set. So typically this would be an Excel file, it can be a CSV file, or it can be a saved file from an earlier version of WinNonlin. Upon clicking Open, there's an Import Preview screen. In this case, the data are partitioned into columns, where each column has one data element in it, and some of the columns also have units associated with the PK. So the time is in hours and the plasma concentration is in nanograms per milliliter. So in my import preview, I'll go ahead and check the Has Units row box. In WinNonlin, the column headers can have associated units so that when one performs calculations, the appropriate units get applied to the output parameters. So with these import options selected, next click Finish and Open. And a brief examination of this spreadsheet shows that there are a number of different subjects identified by the patient column, the subject IDs. The next column, treatment, identifies the formulation name. There's a tablet formulation and a capsule formulation. And then the subjects are divided into two different sequences. Sequence 1 gets the capsule first and then the tablet, and sequence 2 gets the tablet first and then the capsule, hence the crossover design. The period identifies which period the subject got the associated treatment, and then the time and concentration columns, we will actually be using these to perform to make plots and do PK analysis. So I'll start with some exploratory plots. There's some very sophisticated plotting tools in Phoenix. Let's start by visualizing the subjects and comparing the different treatment types. So I'm going back to the data sheet, right-clicking and selecting Send to Plotting, and then XY plot. So in the plot options, there will typically be a main mapping panel at the top over on the right, where one can identify which columns get assigned in the plot to construct it. So a syntax guideline is that an orange column is always required to produce output. So I'll start by doing the required column X, which is going to be the time, and then the Y column will be the plasma concentration. And then in the, you can also use this other information, such as the patient and treatment group, to sort of profile or separate out different plots. So when one uses a group variable, that will take all of the levels within the column and make a figure legend with different colored lines. So for example, if we map patient as the group variable, you will get a legend identifying the patient number. And let's go ahead and compare the treatments side by side. In this lattice conditions section, I will choose the lattice column, which will, at each level of the treatment, make a separate plot, but on the same page. And then since this is PK data, down in the bottom options panel, we'll select the y-axis and select logarithmic to make this a semi-log plot. With these mappings and options selected, I will go ahead and execute the plot. And just as a brief comment, this button is what tells Phoenix to produce output. So whenever you want Phoenix to run something and produce output, it's always this orange cog icon at the top of the application. So upon clicking execute, we have a semi-log plot. On the right portion is the figure legend identifying the different subject IDs. And since a lattice column was chosen, the capsule treatment appears on the left plot and the tablet on the right plot. And a side-by-side comparison is easily obtained. I'm coming back to the object browser, and this item named XY plot is referred to as an object in Phoenix. And in order to organize my analysis, I can rename the object. So I will call this plot overlay subjects by treatment. Okay. You can also do some similar plots. For example, if you want to look at the individual subjects, we'll come back to the input data set and select it. Right-click and select Send to Plotting and XY plot. And again, choosing time for the X variable and plasma concentration for the Y variable. And this time, we will use some different selections. So I will start with grouping by the treatment. And let's start with subject as a page sort. So when using the page sort, each patient will get their own individual plot on a page. Remember to set my y-axis to logarithmic, and then execute the plot. So with the page sort selection, each subject has both treatment plots overlaid, and the subject gets their individual page. And it's very easy to visualize multiple subjects all on one page by using the latticing features in the options. So in the bottom options panel, I'm selecting plot and then uncheck bind lattice to data. This allows you to change lattice selections. And let's do 3 lattice columns and 4 lattice rows. So with a simple selection, this updates on the fly and allows you to visualize more than one subject per page. And one of the nice features of Phoenix as well is if you want to look at a specific aspect, such as this plot output, you can double-click the output plot to pop it out into a window and then maximize the window. So then this is a nice matrix plot of all of the subject PK profiles. Okay, and in my object browser, I'll go ahead and rename this. I'll call this one the lattice plot by subject. So with this exploratory plot, we see the PK profile, and this would be suitable in terms of calculating PK parameters from this data. This is suitable for a non-compartmental analysis. And I will very briefly show some slides related to the non-compartmental analysis in Phoenix WinNonlin. So WinNonlin can analyze PK data that is collected after 3 different types of routes of administration. These can be extravascular, which is typically anything that is not directly administered to the plasma circulation, an IV bolus, which is directly to the blood plasma, and a constant IV infusion. Sample matrices that can be analyzed include the blood plasma as well as urine. The non-compartmental analysis supports sparse sampling or serial sampling and can also handle single dose or multiple dose steady state studies. So this non-compartmental analysis, NCA, does not assume a PK compartment model. So this is a total body exposure to the compound characterized by PK parameters such as the area under the curve, AUC, elimination rate, half-life, and so on. This method is highly dependent on the sampling times. One of the key parameters, which is the area under the curve, is calculated using trapezoidal areas. Because of this approach, the more samples you obtain, the closer the trapezoids will be to the actual shape of the concentration time curve. So in this example slide, looking at a PK profile, obviously this is a very rich profile, but this is useful to illustrate some of the key parameters that get calculated by NCA. Moving from left to right, so starting with the Cmax, which is the maximum observed concentration, and the associated time Tmax, the area under the concentration time curve from the dosing time to the last observed concentration is referred to as AUClast in WinNonlin. And it is basically the sum of the trapezoids drawn underneath the concentration time curve at each observed time point. In the terminal phase, there is a log linear regression performed to calculate the lambda z parameter, which is the negative of the slope of the regression line. In literature, you would often see this referred to as KEL, the elimination rate. And this elimination slope is then used to extrapolate beyond the last concentration to draw a final trapezoid down to the origin and calculate the AUC infinity. Okay. And there are basically 6 non-compartmental PK models provided with Phoenix that are determined by the route of administration, extravascular, infusion, or bolus for both plasma and urine data. Dosing inputs can be either imported from a worksheet or entered manually using an internal worksheet. And some of the options that are possible include selecting the terminal elimination phase with the mouse, specify the AUC calculation and interpolation methods, compute partial areas under the curve, specify a therapeutic range, and set preferred output units for the PK parameters as well as the preferred parameter names. So given this background, the next step in Phoenix will be to set up a non-compartmental analysis of these different subject profiles. So I'll start by going to the input data set, right-click, and then send to. From the submenus, choose the NCA and Toolbox group, and then choose NCA. So this is an NCA object. And the NCA object has a main mapping panel, like the other objects in Phoenix. Required columns are the time and the concentration. So I will map those using these radio buttons here, time and plasma concentration. And then the sort column is used to profile the data. So what happens is when you map something as a sort, it's going to run a separate NCA analysis, for example, for each patient. And since each patient got more than one treatment, we'll go ahead and also map treatment as a sort variable. The carry variables are an optional selection. What this will do is it will take the input column and carry it through and report it alongside with the output parameters. So we'll map both the sequence and the period as carry variables. Underneath the Setup tab, next I will move down from the main mapping to the dosing. In this case, the input sheet did not have the doses recorded, so I will use an internal worksheet to enter dose values. So that's this little Use Internal Worksheet checkbox a bit to the right. Upon checking this, one can select the dosing sorts. If both of the dosing sorts are selected, one would need to enter in individual doses for each patient treatment combination. So this would be the appropriate approach if each patient treatment combination was a different dose amount. If all of these are uniform, if the dose is 100 milligrams for every combination, you can click Rebuild, uncheck the dosing sorts, and then you only need to enter in the dose one time, and this is now assumed to apply to all subject treatment combinations. So if this is a 100 milligram dose administration at time 0, in the bottom options panel, there is a dose options section where one can toggle between the routes of administration. For these profiles, this will be left at extravascular, but you can choose also IV bolus, IV infusion, or dosing defined if there is a mixture of IV and oral data. To assign dosing units, type in the units in the bottom unit box and then press Enter. And this is a single dose study. So up in the top portion, the tau is being left blank. One would enter in a tau if this were a multiple dose study where tau is the time interval between administered doses. But for this single dose study, we will leave the tau empty. And then coming back down into the options section, for the AUC calculation method, the default is linear trapezoidal with linear interpolation. And these are rule sets for how to draw the trapezoids. Since this is PK data, I will choose a linear log trapezoidal method for the extravascular data, where the linear trapezoidal rule is used up to the Cmax, and the log trapezoidal rule is used after Cmax. There are some additional options you can choose in NCA, which include the units. So for example, you can change the units are governed by the input data. The hours come from the time column and the concentration column as well. Units were in nanograms per milliliter. So those will determine the output parameters. And you can actually choose different output parameters if desired. For example, you can report volume in liters and clearance in liters per hour by editing this preferred units column for the associated parameter. The parameter names worksheet allows you to determine which parameters to report in your output. So NCA produces many output parameters, some of which may be more of interest than others. So if you want to not include certain parameters, you can change this Include in Workbook menu from yes to no, and that yes-no selection can actually be dragged down. So I will make a few selections of which parameters I want to report. And the other thing you can do in this section is edit the preferred name. So in the WinNonlin jargon, if we look at the 8th parameter here, this HL_lambda_Z, that is derived from the terminal phase regression and is more commonly referred to as the half-life. So if rather than using this jargon term, I want this output column to be called half-life, I can simply type in a preferred name and say to report it as so. With these options selected, I am now ready to produce the output. So to do so, we'll click the Execute NCA. And this will run the analysis for each patient and treatment combination. In the non-compartmental analysis output, from this Results tab, I will start with the plots. So on the plots, you'll see on each page, each of the profiles got a terminal phase regression, where the blue circles are the observed data points and the green line is the regression line. Another key output is the final parameters in the worksheets. We'll start with the final parameters pivoted. And in the columns here, we see each patient treatment combination with the lambda z, which is the elimination rate, the half-life, which is the custom name set up in the preferred names, and the requested output parameters that I selected. They include the AUClast, AUCinf, AUC percent extrapolated, volume of distribution, and clearance, and some other selected parameters, with the carry variables reported at the end of the parameter worksheet. Another output worksheet that I will draw attention to is the summary table. In the summary table, you see all of the time points, the sort variables, and then the associated plasma concentrations, and this is useful for your cumulative AUC. So as it's drawing trapezoids at each time point, you see the AUC going up until it reaches the AUC last, which is after the last time point in the profile, which is here. Okay, so this is a non-compartmental analysis. So I did a fair amount of work in setting up this NCA. I'm going to very briefly talk about the concept of templates. So templates are designed for you to set up standard ways of doing analysis without having to repeat all of the menu options every time you run it. Okay, so the sources typically refer to the input data. The internal source is something that Phoenix produced internally in the project, where the external source is, for example, the CSV file that I imported. And in the templates, I can do either an object template or I can do a workflow template. Let's start with an object template. So to make a template of this NCA, back in the Phoenix application, in the object browser on the left, right-click the NCA object and select Export. And the standard file format for templates is the WNLT file, which is a Phoenix template. And I'm going to call this my NCA single dose template. So what this template remembers is all of these options that I chose in the setup, such as the parameter names and the output units. Okay, so with the NCA outputs obtained, let's go back to the Results tab and think about presenting all of these final parameter results in a report quality table. We'll take the final parameters pivoted worksheet, right-click it, and select Send to Table, and then Table. So this is a presentation table, and there are table templates built in. I will use the default template for this example. And thinking about what to present in terms of outputs, we'll start by choosing the patient as a row ID. This will be a vertical listing of the patient IDs. And we'll stratify by the treatment. So this will make a separate table for each treatment, the capsule and the tablet. And then the data output will be a PK parameter that I want listed and summarized in the table. So let's choose some commonly used parameters such as the lambda z half-life, Tmax, Cmax, AUClast, AUCinf, volume, and clearance. So these will be the data variables in the table. Next, to give the table a title, down in the bottom options panel, we'll select the captions. And in the caption box, we'll enter my table title. And click Add. Next, let's look at the precision and alignment. This is where you can format the numbers. So these are for the outputs. So for the patient ID, for example, the patient ID is typically an integer. So I don't want this patient ID to be 1.00. Instead, I just want the integer. So I can set the decimal places to 0. Then for output parameters, I might want a different selection, such as significant digits. So I'll set the output PK parameters to 3 significant digits. Tmax will leave at 2 decimal places. And so on through the different parameters. Optionally, you can also display descriptive statistics at the bottom. And these statistics are summaries within the column. So if you were to look at all of the, for example, AUCs of every subject, you can calculate things like the N, mean, standard deviation, standard error, and so on. And this is displayed in the form of a checklist. So you can either select all to check every type of statistic, clear all, or pick and choose individual statistics of interest. With these statistics selected, we'll go back to the options and choose the precision of the statistics. So I will choose the default to be 3 significant digits for the statistics, and I'm going to change the N parameter to 0, since that's just a number. And let's go ahead and run this table to produce output. So we see the structure of the table is set to, so the title, caption across the top, summary PK parameters by formulation. The first table is for the capsule. So looking from left to right across the table, we see the capsule listing for the formulation, the patient IDs vertically, and then each column is a summary PK parameter with the requested statistics at the bottom. And you can do some nice formatting features, such as selecting the table and make a page break on the row stratification, which will break these 2 tables into separate groups. You can also do some nice formatting for the column titles. For example, let's say that you want to replace half-life with T1/2. So I will choose capital T subscript 1/2. And let's say for the AUC infinity, I'll replace this with AUC subscript and then the infinity symbol. And let's go ahead and run this. So we now see that the reformatted column name, T1/2, I forgot to click add here, and the AUC infinity. And you can see that also in Phoenix that if something is missing or you want to sort of fine-tune some of your outputs, it's very simple to make a minor change, such as adding this AUC infinity, and then simply re-execute the table. Okay, and if this is a standard PK table that I might want to use over and over again, I can again make a template. So I'm going to first rename this. Call this a PK summary table. And then right-click it and select Export. Choose Phoenix Template. And then this will be my PK summary table template. From the NCA, I'll do one other type of output plot. Let's say, for example, we want to do a different plot than the XY scatter plot. We'll do a box plot comparing the Cmaxes. So I'm going to the final parameters pivoted from NCA, send to plotting, and this time choose the box plot, where the Y variable is the Cmax, and then grouped by the treatment. So this will compare the different treatment formulations, and this shows the 5-number summary of the Cmax for the capsule and the tablet. So I did a fair amount of work setting up all of these analysis steps and made a workflow. What I will do at this point is save my project. So save project as. I'll call this my 2-period crossover study Phoenix project. And then I can load this project at any time in the future to look at it. Now, this series of steps we refer to as a workflow. I'm going to rename this and call this my PK analysis workflow. And let's say that we want to save all of these steps as a standard template to reapply to new data sets. So that's where we get this concept in the slide of sources and data links. So the data link object is denoted by this yellow object in Phoenix. And when you connect the external source to a data link, this expects to get an input data set that is similar to the 2-period crossover study that I imported initially. And what it does is it knows to forward that data set on to all of these different plots, NCA analysis, table, and so on in the workflow. Okay, so this external source is now mapped through all of these series of steps in the workflow. So let's set up a workflow template. So to do that, the first step I will do is set up a data link. So with the workflow selected, I'm going to go into the workflow diagram on the right panel and right-click a blank area in the workflow diagram and choose the option Connect External Sources to Data Links. When I do that, this new data link object gets created. You may have noticed that the object's turned a pink color. That's a standard context clue in Phoenix that just means that the analysis needs to be refreshed, and one can refresh the analysis by executing the workflow. So in my prior examples, I was executing just an individual object, and now in one step I'm executing all of the objects together in the workflow. So at the level of the workflow, I can easily scroll through all of my PK outputs and see them in one convenient view. Now that the data link is established, let's make a template of this workflow. So to do that, it's a similar step. We'll go back to the workflow in the object browser, right-click it, and select Export. Again, choose the Phoenix template WNLT extension, and this one will be named the PK analysis workflow. So the workflow template is saved. And at this point, I will close the project. And now let's say this is 6 to 8 weeks later, and I want to perform a similar analysis on a new data set without having to construct all of the different option steps from scratch. So what I will do is make a new project. I'll call this Clayton from crossover template. And the next step is to bring some data into Phoenix. So I will import a new data set. So before I used the 2-period crossover study, now there's a new data set named Clayton. Again, using the import preview, this data set does have units for hour and concentration. So I will check the has header row and has units row checkboxes, and then click Finish to import the data file. To bring back the workflow template, it's again from the File menu, choosing Import, and this time choose the template, which is this PK analysis workflow template. Click Open. And we now see that that series of steps that I went through constructing here is all imported from this template. So now, how does one get the data to run through all of these objects? Well, the key to that is to use the data link. So I'm going to choose the data link object. And this data link object anticipates columns that are similar to when I created the template. So these are the columns that were present in the 2-period crossover sample data set. And what you can do is drag the new data set into the data link and then assign variables. So some of these variables automatically mapped, the period and the sequence, because they have the same name as before. Others do not. They're named slightly differently. So all you do is say that the subject from the new data set is equivalent to patient from the template. The form is equivalent to treatment. Hour is equivalent to time. And conc is equivalent to C sub P. We'll go ahead and execute the data link. And then go and select the workflow and execute the entire workflow. So this is going to rerun all of these analysis steps on the new Clayton data set and produce the Clayton-specific outputs. So starting with the overlay subjects by treatment, you see that there's some differences between the capsule and the tablet. Maybe there's more of a lag time on the capsule than the tablet when comparing them side by side. The lattice plot by subject, I can very easily see the different subjects that got these two different formulations, C and T. Look at the NCA for the different formulations. Some of these profiles don't have a terminal regression because there must be at least 3 points in the terminal phase with a negative slope in order to get this lambda z regression. But that's okay. It will still calculate AUCs for the incomplete profiles. You can see that by looking at the final parameters pivoted output. So everyone gets an AUC and a Cmax. Those profiles that did not have enough data in the terminal phase will not get a lambda z or a half-life. The PK summary table is also constructed from all of the different profiles. Box plot comparing the Cmax for the capsule and the tablet for this new data set. And so on. I'll go ahead and save my project here. This is a new project, Clayton from Crossover. And with a few minutes remaining, I think what I'll do next is cover a special case that applies usually to toxicokinetic studies. You've seen that most of the data here has been very rich in terms of the number of samples collected. Okay, so in this example, WinNonlin is able to do the non-compartmental analysis on sparse data. What it does, so for example, if each animal only provided one sample or a couple of samples, not enough for a rich PK profile, you can pool the subjects, and the sparse NCA method will calculate the mean concentration curve for each unique time value. And then it uses an algorithm by Nadelman and Gia so that the inter-subject variability on Cmax and AUC last can be obtained. And this method gives you the standard error of the Cmax which is the sample standard deviation of the y values at time Tmax divided by the square root of the number of observations at Tmax. Then the standard error of the mean AUC is calculated by methods described in Nadelman and Gia with the Holder modification, and the references of these methods are applied here. So I will go ahead and set up the sparse NCA. Let's do some brief exploratory plots to look at this data. I'm going to send this to the plotting, and then XY plot. And I'll set up a semi-log plot where all of the animals are overlaid. And this figure legend will be useful to identify subjects. So for example, subject 1, which is the yellow circle, we see that this animal only supplied 3 observations. And then animals are assigned to different sampling schemes where each animal only provides 3 observations, but there's a staggered sample collection interval such that now the overall mean profile would have 6 observations. We'll call this overlay individuals. And then what you can also do is set up a mean plot. Why don't we do a mean plot? To do that, one must first calculate the means of the concentrations at each time point. We'll do that using the plotting tool, XY plot. I need to calculate the means using the descriptive statistics tool. So in descriptive statistics, we can choose the summary variable as the concentration, and then the sort variable, which will be the time points. And now at each time point, there is mean concentration, standard deviation, standard error, and so on. And then you can use that to set up a plot. I'll go ahead and select the descriptive stats output as the main mapping data set for my mean plot. And let's select the time value for the X, the mean for the Y, and then for the error bars, this is over at the right portion. I'll choose the standard error as both the upper and lower bars. And then make the mean plot. So I'll go ahead and change the x-axis to cover the range of observations here. So this is a custom range with a minimum of 0, maximum of 24, and then edit the tick marks so that they're nice round integers for the mean plot. And then to set up the non-compartmental analysis with the Sparse method, go back to the input data set and then send this to NCA and Toolbox, and then NCA. The first step is in the options panel to check the Sparse checkbox, and at which point the subject now becomes a required mapping variable. So we'll map the animal ID to subject, time, and then concentration. Then under the Setup panel, select Dosing, check Internal Worksheet, and then we'll enter in the dose, which is 5 milligrams per kilogram at a time of 0 for all animals, and then execute. So in the Sparse NCA, we have the standard non-compartmental analysis parameters, with the addition of a standard error for the Cmax, which is this SE_Cmax, so you can compare the standard error to the mean, as well as the standard error for the AUClast. And then on the output plot, this is the mean plasma concentrations for the pooled subjects. So we have approximately 10 minutes remaining. That concludes my planned presentation. At this point, I'd like to open up for the Q&A. So I'd like to find out if anyone has any questions. And as Suzanne indicated, you can actually go to the Q&A section to submit a question by chat.
All right, so we have a question. Chris, can you tell us how can Phoenix results be sent to Word or Excel?
Sure. So, so far we've been doing everything in the Phoenix application. It's very easy to send the outputs out to Word and Excel. Why don't I go ahead and save this project? And we'll load one of the previous projects. And I'll start with Microsoft Word. So let's say, for example, we want this nice PK summary table to be in Word. Let's go ahead and use the File menu and choose Word Export. And I would suggest using the picking individual results. So what you might want to do is export a plot. So this is a result plot. Let's export the plot and the PK summary table to Word. And you can choose options such as portrait and landscape and so on. And it's very easy to just click Export, and it will port these outputs to Microsoft Word. So here we have the plot and the tables as well, exported to Word. And then to export to Excel, one can take any spreadsheet in Phoenix and export it to Excel. So let's take, for example, these final parameters. The final parameters pivoted, I'll right-click and select Export, and then choose the Excel format. And say final parameters pivoted from to period crossover. There's a prompt of whether you want to output the column headers in units, and I'll click OK to this. And then from my export, in my export folder, I can then just open this directly into Excel and see all of the PK parameters from the MCA. Okay. Suzanne, were there any other questions?
Yes. One of our listeners would like to know, do we have a demo version of the software available?
Demo version of the software. Yes, you can actually get a demo version of the software by contacting one of the sales representatives. The contact information is presented in the last slide, which we'll show. So in your area, just contact your lead person, and they can set up a evaluation for you.
And this looks like this will be our last question. How can I make a mean plot with error bars?
Okay. Mean plot with error bars. Okay, so I think I covered that. in the sparse sampling example. So we'll go back to the NCA of sparse data. So to do this, we first calculate the means using the descriptive stats tool, and then use this descriptive stats output as the input for the mean concentration with error bars. So if I send the statistics output to plotting, and then XY plot, then choose the time val as the X and the mean as the Y, and choose, let's just do the upper error bars this time. You can do upper and lower, or just simply choose the upper if your data are very close to the x-axis, for example. So this is the example with just the upper. It's very simple to change it to both upper and lower. Just go back to the mapping panel, choose lower, and execute. So Suzanne, are there any other questions?
Yeah, it looks like we have one final question. Is it possible to calculate renal clearance by combining plasma and urine data?
Yes, it's possible to do that. Why don't I load an example project that has exactly that. So I'm going to load a project. So let's look at this example data set where we actually have both plasma and urine data collected for various subjects. Okay, so we have the plasma and urine. We examined the plasma NCA, so we used a data tool here to split. This is the split worksheet, and we split on matrix. And what that does is that makes a worksheet of just the plasma data and a second worksheet of just the urine data. These are then sent to NCA. Since we already covered plasma earlier in the presentation, I'll just briefly show the urine data NCA. So what you do is go down to the bottom options panel and choose one of the model urine types. And in the setup panel, there are some additional mappings that are done because the urine data is represented by the midpoint of a collection interval. It's defined by a start time and an end time. And then the urine, the concentration measured from the urine sample as well as the volume of the urine sample. And this produces outputs such as the maximum rate, midpoint, area under the renal curve, amount recovered, percent recovered, and so on. So we take some of these key parameters and then combine them using the merge tool. So we're taking the final parameters from the plasma NCA and the urine NCA using the merge tool to produce an output workbook that has selected outputs. So the AUClast, Cmax, and Tmax came from the plasma, then the amount recovered came from the urine. And what you can do is calculate the renal clearance by dividing the amount recovered from the urine by the AUClast from the plasma. And this can be done using a column transformation. So what that does is it divides all of the values in one column by all of the values in the other column. So in this column transformation tool, this renal clearance calculation is performed. And then this last object is just to simply reduce the units to the liters per hour. And so this is an example of a workflow to create renal clearance, and this can very easily be made into a template like I demonstrated earlier with the crossover study. You would simply set up a data link and then export your workflow as a template to be reused for future renal clearance calculations on new data sets.
Okay, Chris, thank you so much for that presentation. A reminder to our audience that a link to a replay of this webinar will be emailed to you within the next few days. Chris again is showing us a slide that provides information on whom you may contact with questions you may have regarding Certara's products and services in the Americas, Europe, India, and Japan. On behalf of Certara, I would like to thank you for attending today's presentation. This concludes the webinar, and you may now disconnect.